Okay. Because we have such a rich roster of speakers today, I'm going to try to be relatively quick in talking about the progress we've made in Genie recently. But this is the time when we do want to reflect just a little bit as we complete another year's worth of Genie work. And I want to remind people of the commitments we made for work we're going to do in Genie Spiral 5, give a little bit of a report card, and at least identify the top-level goals for this upcoming year, and tell you where you should be for the remainder of the GEC to help participate in defining those goals and beginning to push them toward fruition over the upcoming year. I'm going to do all of this in about 7 or 8 minutes, so I apologize for what will feel like a pretty brisk pace. So these are goals and an actual PowerPoint slide simply lifted from GEC a year ago in October 2012. We identified really one very top-level goal for Genie, which was increased adoption in the lab and in the classroom. We had a couple of supporting tasks to get us there. One was to continue the rapid growth and rapid deployment of Genie resources nationwide. And this is primarily Genie racks, but branching out to more campuses and more regional networks along the way. Some of the speakers today, I think, will do a very nice job of laying out the different points and the different collaborative efforts that are necessary to make that happen. But I think we've been very successful over the past year. I'll show you a few maps. The second supporting goal was to put together a cleaner, more consistent experience for experimenters and educators coming to Genie. And these two goals, again, were with the specific purpose of driving a continued, steady increase in experimenting classroom use. So how have we done? We've been looking at this graph for quite a while now. And is that blue line even legible? I'm sorry? Okay, well, I will tell you that there is a line that runs like that. It goes up at the end. And it goes up at the end to the tune of about slightly over 1,200 unique experimenters, which is really, a wondrous number, and one we want to continue to see grow. I also like looking at this histogram, which is, rather than the number of cumulative users coming to Genie, this is the number of active users by quarter. So you'll see that in any quarter, we have, this past quarter, about 325 or more active Genie users. So these are not people who came once and went away. The level of activity continues to build as well. So these are two nice graphs to look at side by side, or over, under. How are we doing on making resources available? Well, we've been pushing Genie racks out at a very nice rate. We are a little behind where I hoped we would be this year, or at this point in the year, but the year is, not quite over yet. And these racks are becoming available for use. There are a fair number that are already ready. There are a number in various stages of test and deployment. Genie WiMAX, that rollout is essentially complete and is having excellent success in a variety of research and educational efforts. I'm going to show you a few maps. This is the map of Genie racks, either available or somewhere between shipped and up. When we add in the additional planned racks that will be shipping soon, the map looks more like this. As you know, we're very excited about the spontaneous rack phenomenon. Spontaneous racks are racks that are deployed by campuses acting on their own, by researchers spending their own grant money, by commercial establishments that are building and deploying Genie racks for their own interests. So this is a really excellent validation of the rack concept overall and an excellent path to continued growth. This is a relatively small number at this point, but the pace is accelerating here. And when you put it all together, we're starting to look at a pretty rich landscape of Genie racks. We had an excellent opportunity yesterday to tour Thanasis's lab of little yellow mobile clients for Genie WiMAX, and it's just one instance of the WiMAX deployment. This is what WiMAX is looking like now across the US, and I couldn't help putting up a picture with everything. So we've been very successful, and we're continuing to work hard to deploy more Genie assets within the US. We're also working hard, and in a moment, Brecht from iMinds in Ghent will tell us a little bit about the efforts that we've been putting in place to extend the reach of Genie experimenters and of our peer testbed experimenters internationally through international federation efforts. So there's a strong effort underway to define a common API, to set aside some shared infrastructure, and to create the opportunity for all of us to conduct experiments that are not limited to the size and scope of our particular testbed deployment. Genie is a US project, but to reach out through shared resources into transcontinental experiments. So that's a brief report on goal number 1, deploying additional resources. And I have an even briefer report because Vic will come in and fill in some additional stuff about work we've been doing in improving the experimenter experience. About a year ago at GEC in October 2012, we announced the availability of the Genie Portal on a sort of experimental basis. There's another one of these illegible lines that climbs even more aggressively from essentially 0 to somewhat over 800 Genie Portal users in that year's worth of time. And the Genie Portal is now becoming really a very key way for researchers to get at Genie. There are other ways, the other ways still work, but the Genie Portal is becoming more and more popular. We've had great success teaming with InCommon to make the portal more accessible to more users, and we currently have about 60% of our users coming in through InCommon. And we've gotten some very positive feedback from both researchers and educators on their ability to use the portal and simply reduce the friction, the challenges of entering. We've also done a lot of work in LabWiki and Genie Desktop, 2 integrated environments for managing longer-lived and more complex experiments. And this is an effort where this is an area where we're going to put in a bunch more effort over the coming year. So the promised looking to the future, what thrusts are we launching now? So these are all consistent with, I believe, most people in this room have seen Genie Solicitation 4, and we're in the process of launching several new projects that support these goals. So one is continuing to expand on the tool support with a particular emphasis on long-lived experiments, on sophisticated experiments, and on sophisticated topologies. For those who are interested in contributing, there's a session this afternoon developing Genie tools. I hope people will show up and engage in that discussion. We're having a continued push on Genie-supported classroom and curriculum, classroom use and curriculum development. Vic will talk about that and give an outbrief from our Genie and Education workshop on Saturday in about a minute and a half. We are launching several new shakedown experiments with an intention of pushing Genie's boundaries, verifying that the claims we make for what Genie is good for are accurate, and for stretching our Genie user community into new science domains. Tuesday morning, there's a session titled New Genie Shakedown Experiments, where we'll get a preview of some of those, and I invite people to attend. And also this afternoon, there's a session Planning Genie Operations for the Future, where we're going to talk some about our fourth thrust over the upcoming year, which is readying Genie for continuing operations and preparing an ongoing community as we move past the phase of intensive Genie development that we've all gotten used to and into a phase of continued operational usage. We're starting a lot of new work this year. We will need people in this room to help. Please come to these sessions. Please stay engaged over the next year. We've got a lot of work to do still. One quick announcement is two people who are going to be key in helping push these efforts along. We have introduced two new members to the Genie architecture team, Ilya Baldin from Renzi and Mike Zink from UMass Amherst. And I trust they're both hiding here somewhere. There's Mike, and there's Ilya. So many people here know Mike and Ilya, and they've made wonderful contributions to Genie. And I think that their particular expertise is going to be highly relevant as we work in additional educational efforts and work to expand Genie's user community into more scientific domains. So thank you, Mike, and thank you, Ilya, for agreeing to take on this work. I guess I went a bit over my promised 7 minutes, but I really do want to sit down and let Vic talk a little bit about work we're doing in experimenter support and education.
Good morning. As Mark said, I have a brief update on what's happening with experimentation and use of Genie in the classroom. I'm not going to spend much time on this illegible slide. Suffice to say that we've had about a 20% growth in the number of users since the last GEC, from about 1,000 to 1,200 users, which is very exciting. Even more exciting is are the new experiments that are starting up right now. We have shakedown experiments starting up that will be stressing Genie in a variety of different ways. Some are non-IP experiments. Others are large-scale experiments, so using a large number of resources within Genie. Experiments that require high throughput, long-lived experiments, and services. So these are not experiments that you just run and shut down, but will be around for months or even years. Experiments with opt-in users. So these are people who use these long-running services to use them. And tools for scientists from other domains, computational genomics, advanced manufacturing, and so on. Many of these experiments stress Genie in multiple ways. So the same experiment might be a high throughput experiment that also has opt-in users. If you want to learn more about these, there's a session on Tuesday morning at 8:30. The use of Genie in the classroom has been widely successful. I'm not going to have you count all these classes. There are actually 9 listed here, and these are classes just in this fall. And there are many more queued up to use Genie in the spring semester. If you are planning on using Genie in your class or have used Genie in your class, please let us know. I often hear about people at this GEC or other GECs, people telling me that, hey, I use Genie also in my class, and we would like to list you in this, have you in our list. Speaking of curriculum support, there are new projects starting up that are building coursework modules for Genie, so modules that can be used by an instructor in the classroom to explain concepts or assignments that student handouts and instructor guides for networking-related assignments. Some of these modules are based on widely used GENI networking textbooks, and one of the projects is developing coursework in a massively online format. If you're interested in GENI in education, there is a Birds of a Feather dinner tonight at 6 p.m. Just email me at bthomas@bbn.com if you're interested in joining us. Speaking of the new experiments, there's also a BOF dinner for people interested in running long-lived experiments or services in GENI. And if you're interested in joining that dinner, there's a link on the agenda page where you can go and RSVP. We organized Train the TA training session earlier this semester, and this was tremendously successful. We were expecting half a dozen to 10 people sign up. We had 31 people actually do the class. We had to run the tutorial twice so we could keep the class sizes smaller. These were run over Webex, and what was really gratifying was the feedback we got. Of the 22 people who responded, 17 said they had little to no experience with GENI before they took this tutorial. After this tutorial, they felt comfortable. 20 of them felt comfortable leading or assisting with a GENI-based lab. This is a screenshot of what the Webex session looked like. Here we have Sarah and Nikki teaching a class. See the list of attendees, and this is how we shared screens. It was challenging, but it worked well. We will offer this training again in the spring of 2014. And also, new next year will be a winter camp. So you might have heard of the successful summer camps that we've been running, week-long summer camps. We will try a similar camp in the winter of next year, early next year. If you're interested, please talk to Kaiki, and there will be an announcement about this soon. We will be having GENI tutorials at these conferences, 6C in March, and this is a cloud computing conference also in March. We have actually 3 weeks of tutorials lined up in March, 6C, followed by the cloud computing conference, followed by the GEC. So it's going to be a busy month for tutorials. Before I go to the next part, which is the outbrief from the educator workshop, I wanted to mention 2 other BOF dinners that are happening today. There is if you're interested in instrumentation and measurement related topics, there is a BOF dinner. There's a link to the RSVP page on the agenda page. And there's also one on GENI operations. So if you're interested in operations, you can attend that dinner. So this is an outbrief from the education workshop. Unfortunately, neither Jay Eichart nor Kevin Jaffe or Jeannie Albrecht, who ran the workshop, could be here with us today. So they sent me their slides. The workshop was on Saturday, and the goal was to encourage the use of GENI in undergraduate and graduate classes. 30 people from big and small schools participated, and we had Jim Kurosi do the keynote, which was very well received. There was a lot of practical advice on using GENI in the classroom. Some of the participants had actually used GENI in the classroom, and so they gave advice to people who had not, who were thinking of using GENI in the classroom. And there was also descriptions of the new projects, education-related projects starting up. There were a lot of discussions on the pros and cons of using a virtual test bed versus a test bed where you can get your hands on, actually plug cables into switches and so on. And there was a lot of spontaneous collaboration that happened. There were breakout groups, and people shared ideas and talked about how they can help one another. The feedback I haven't seen the feedback, but Jay tells me the feedback was excellent, and she would like to do a follow-on at GEC19. And that's it for my outbrief.
So before I introduce our featured speaker, I want to make sure he's here. Ian, I can't see. Oh, good. Okay. So Ian Foster is the Arthur Holly Compton Distinguished Professor of Computer Science at the University of Chicago and is one of the leaders in the development of grid computing. And he'll talk to us, I'm sure, a little bit about that today. But as I tried to hint before, the main purpose in Ian's talking to us here is to say a little bit about the challenges that we all share in management of shared cyber infrastructure. This is it's an emerging challenge in the grid community. It's an emerging challenge for us in Genie. I think we've had tremendous success in finding ways that Genie can derive leverage from the fact that we are deploying limited resources that are new, sharing resources that are already available, and then making them universally available for research use. This is a model that is likely to continue growing in terms of supporting scientific community, scientific research community-wide. And there are a bunch of challenges we share together. So Ian's going to talk a little bit about work that he's been doing in the grid community, and we should all be thinking about how we're going to apply that in our work in Genie. So Ian, thank you very much. You're not Ian. I never trust that, but yeah, that's okay.
Okay. Well, good morning, everyone. Thank you very much for the invitation to speak. I've long followed Genie from afar, so it's fun to come here and learn a bit more about what's going on. It seems like a lot is happening. So I was asked to speak to this general topic. So this is the title I provided. It's a rather dull and outdated title. Maybe this one will be better. I think it sort of tries to capture the same thing using the buzzwords of today. So I want to talk about work we've been doing in this so-called grid community over some years, and I think some things we've learned, some experiments we've been undertaking recently in working out how to take technologies we've developed and make them available to many more people using the concept of software as a service. So I think we're all familiar with this term cyber infrastructure. We should say a few words about that. It's was coined by, I think, an NSF director to indicate, as we say here, the word sociological was interesting in there, but I won't speak to that. But I think that's really the hard part of most of what we're doing. But certainly a technological solution to the problem of creating distributed virtual systems that can be used for research. And I pursue that problem mostly from the perspective of scientists who are engaged in problems in the physical, biological, or social sciences, but certainly similar problems arise when one is working in the computer sciences, and that is, of course, what Genie is about. So this term, cyber infrastructure, has also been called a number of other things. The word grid computing was popularized in the, I guess, the 80s, 90s, I suppose, 90s, by various people, including myself, and initially, I think the vision of grid computing was purely a revisiting of a very old theme, one that dates back to the 1960s, of providing computing as a utility, as a service, something that nowadays is, of course, known as cloud computing. But from the very beginning, we also recognized the importance of being able to enable not only individuals to access remote resources, but for communities to come together and function effectively in a distributed environment. And the term virtual organization was coined at that time. Well, we think we coined it. Actually, the business organization literature uses it before us. But referring to groups of people that need to engage in some collaborative work that requires resource sharing, and then the tools, therefore, that allow us to create such capabilities. So grid computing had some early success and substantial adoption in the physical sciences, in particular within the high-energy physics community. Recently the Higgs boson was, of course, discovered. And fortunately, before Professor Higgs had passed away, so he got a Nobel Prize. But the Director General of CERN was kind enough to acknowledge grid computing as one of the 2 or 3 things that really made the Higgs discovery possible. In support of that goal, the high-energy physics community constructed a very substantial distributed computing system that links more than 200 sites, tens of thousands, I think actually hundreds of thousands of CPUs, and is used by thousands of people. And if you may not be able to read the details here, but if you go to the LHC computing grid page, you can see on the right a list of all the so-called virtual organizations, which basically means groups that make use of different subsets of resources within the LHC computing grid. And I've just highlighted one of them here, the Atlas experiment, one of the larger ones, which is at this moment, last night, was running over 100,000 jobs, had 16,000 queued up, ready to run. Some other data here. This is some data from our own Globus software showing what sort of things it's getting up to. So just in 1 month, we're engaged in almost 400,000 data movement operations, moved 30 petabytes of data. In other contexts, processing hundreds of thousands actually millions of distributed computations. So in some sense, grid computing has been successful, at least within this narrow realm of high-energy physics. But I became quite frustrated as these developments progressed in recognizing that although we'd been able to produce software that allowed large communities with lots of resources to create and operate large virtual organizations, these technologies were not easily transferred to smaller communities where, of course, most science is done. So most science is performed in small labs, a single PI, maybe a few postdocs, a few students. These sorts of people were not able to engage in this sort of distributed science in an easy manner. And at the same time, the computing demands on these people, these groups, was growing. So if we look at the sorts of things that science involves, this is a rather ad hoc list, but I think you'll recognize some of these steps even in computer science, certainly in the biological and physical sciences, these steps apply. These are the sorts of things that people have done for years using notebooks, then PCs, Excel spreadsheets, other similar technologies, but that are becoming increasingly challenging to perform because the volumes of data in particular that they have to deal with are growing rapidly. So biological scientists, for example, now need to work with terabytes of data thanks to advances in genome sequencing technology. So I started to wonder, along with various colleagues, what it would mean to take some of the technologies we'd developed and distributed for many years as basically tarballs, and instead deliver them as cloud services, to basically provide research, discovery IT, research IT as a service. And so that's a process we've been engaged in for some time, and I think, as I'll say, it has led to some successes in terms of adoption. So there's lots of things on the left there in this list that we might undertake. We decided to start off with an activity that we had spent a lot of time on understanding how to optimize and manage in the context of large grid deployments, which is data movement. You might say a very mundane task, but still one that dominates the discovery time for many people, certainly not all by any means, but quite a few. And so we developed a thing called Globus Online, which provides file transfer as a service. The basic idea is that if you want to manage the movement of one file, 100,000 files, 10 million files from one place to another, you don't need to install software or assign a grad student to that task, but instead you hand off a request to a cloud service that we operate called Globus Online, which actually then manages the process of moving and synchronizing, or synchronizing files between a source and a destination. The management logic all sits in a cloud service running on Amazon, in fact. The actual execution of this transfer, the actual data movement occurs over the commodity internet, or ideally something faster like Internet 2, without any data passing via this cloud service. And we have found actually that the results of this have been quite remarkable. So, so it has a fun web page, and that counter ticks over, which is fun to look at if you've got nothing better to do. But the adoption has been quite tremendous. So we've seen campuses around the world, particularly in the US, of course, adopted as the primary mechanism by which they provide access to their campus computing resources. We've seen the number of registered users grow reasonably quickly to 12,000. We've moved more than 25, more than 25 petabytes, more than 1 billion files, while achieving very high availability using cloud services. So we've learned a lot about what it means to operate high availability, highly reliable, secure, high performance cloud services for science, which I think is I'm sure we're learning things that people in the industry understand very well, but there are also some unique issues that arise in the scientific environment. We've also more recently added in the ability to share big data. So one has, I guess I've lost some colors there, just as the previous speaker did, but you imagine a data source there with some directories and files one wants to share. We want to allow people to select those files and set permissions on them, basically specifying very simple access control policies without having to have any engagement with the system administrators or indeed any software running at the data source, and then allow the remote users to access data. So that's something that seems to be proving tremendously popular as well. So what I've been describing up to now is basically, I think, a lesson that I believe is relevant to a lot of things, which is thanks to advances in networking capability, the widespread availability of highly reliable commercial cloud services, it becomes quite feasible to start taking capabilities that we have traditionally delivered either at the individual PI level by software they install, or at the large or small project level by software that someone installs and operates, and deliver it via a software as a service paradigm, achieving the economies of scale and I believe greater reliability and capability that is possible if one pursues that approach. And that's what we've been doing, first of all, with Globus Online, taking this transfer service and sharing service and delivering it via software as a service. We've been doing that, we're building on technologies we've developed, such as Grid FTP in the Globus toolkit. We provide some local software one deploys if you want to interface your campus storage system to this system. And this is being adopted by various groups around the country. But what I want to talk about for the rest of this talk really is another component that we've built in here called Globus Nexus, which is maybe of interest to some of you here, and I think also shows perhaps where one can go with the software as a service approach that is a bit more interesting than simply data movement. So in order to support data sharing, we need to provide identity, group, user profile capabilities. So Globus Nexus, as we call it, supports the sharing and transfer service. But more than that, it also, because we provide REST APIs to them, it provides basically a platform as a service capability that quite a few groups are starting to use, simply writing web-based or non-web-based applications that call out to these platform as a service capabilities that we provide whenever they need to do anything to do with identity, groups, profiles, or data movement or data sharing. So let me say a bit more about that Globus Nexus capability. So if you, what I see as I look at the world of collaborative science, people building what at various points have been called portals, gateways, hubs. There's a number of different terms that are used, systems that are designed to support collaboration within a small or large scientific community. I see, first of all, certainly a need for a common set of capabilities, assigning identities to their users so they can, they may want identities so they can track usage, control usage, report on usage. They need to manage user profiles so they know what capabilities users have, and they need to be able to organize users into groups for purposes of authorization. This set of users is allowed to use this set of resources, this set of users is allowed to use that set of resources. Providing high-quality implementations of such capabilities is challenging. The security protocols that you're using are complex. They are frequently evolving. It wasn't long ago that SAML was the way everything was done. Nowadays, OAuth is becoming increasingly important. That's a whole new technology stack to understand. And operating these services in a way that provides reliability, availability, et cetera, is challenging. So what one finds if you look out across the science space is lots of little identity islands implemented in somewhat different ways, often not particularly well because the people aren't specialists, and not interoperating very effectively. So Globus Nexus, as a platform service, we've been seeking to understand what it would mean to take these capabilities that we developed again for one particular application, Globus Online, and provide it as a service that we could outsource capabilities to many different communities. And so what the resulting service provides four things. So identity provisioning, create and manage what we'll call Globus identities or Nexus identities. So we'll talk a bit, maybe I'll say a bit about in a minute about why we decided we needed to operate as an identity provider, given that there are lots already out there. Allow people to link a Globus identity with other identities, which you can then use to authenticate to Globus Nexus or to other services that we arbitrate access to. These other identities can be things like your campus identity and common identity, some identity that's required by a particular storage system or supercomputer center, the Google identity if you want to mediate access to Google groups and so forth. We provide what we call a group hub, a set of capabilities that allow users, not system administrators, to create groups, manage who's allowed to join groups, control their visibility, and then export those groups so they can be used for authorization decisions. And then finally, a set of profile management capabilities that let you associate attributes with your identity, and if you like, delegate to others the right to associate attributes with your identity. And then we can use those attributes for various purposes, for example, in group admission. So let me say a few words about each of these things and then a bit about how they use. So identity provisioning. Many projects already run an identity service of their own. Others realize that it's an unnecessary distraction from what they're really trying to do. So for example, the DOE Systems Biology Knowledge Base project, KBase, fairly new, a very large Department of Energy project. They decided to outsource their identity provisioning task to us. So we manage about 700 identities for them at present. So if you go to the KBase page and sign up, which you're welcome to do, you'll go to a Globus Online, basically a skinned page that we provide to them. The Identity Hub capability is a bit more interesting. So here, as I said, the goal is to allow people to link identities with from other federated identity providers with this Nexus identity. So we believe strongly that we live in a multi-identity world, and that's not going to change. When I was young, I used to believe we could come up with some universal solution, but that's clearly not the case. A typical science user will have an in-common credential identity. They will have a Google identity. They'll have, if they're a supercomputer center user, they're an Exceed identity. They may have other identities that will be used to access other supercomputer centers or storage resources. All of these things are necessary, at least at the moment. Maybe in some future time they won't be, but I doubt it. And they're not actually so bad as long as they are managed appropriately. So what we do is provide a way of linking easily linking an identity with your Globus identity, and then making it very easy and intuitive as to when you access a particular resource, which identity you need to provide, and then handle the authentication process for the user, either directly or else via the use of the OAuth protocol, so that we can hand off the authentication action to the remote server, and the password doesn't need to pass via the Globus Online service. And then once you've linked an identity, you can then use that to authenticate to Nexus for all subsequent interactions. You can also use our federated IDP or any linked federated IDP to authenticate to third-party services. So, for example, we've integrated Nexus with Exceed, the NSF supercomputer network, but also Jira, Zendesk, Drupal, Globus Online, Confluence, and a few others. And as a sort of a final nice feature, we cache delegated credentials so that you can avoid having to repeatedly authenticate when one is engaged in long-lived computations. And there's a fairly sophisticated set of capabilities for renewing credentials and determining what needs to be renewed. So this is what it looks like in practice. This is, I can't read the fine print, so you probably can't, but it's someone's identity management page showing the set of identities that they have linked with their Nexus identity. You see down the bottom perhaps the interface for adding one. Here's a exemplar of it being used in practice. It's a biomedical science application. So someone is creating a Nexus identity, linking in their campus and Exceed identities, then authenticating this is the application is called Berman, with their campus ID, going ahead requesting a transfer that perhaps requires a campus identity and a Nexus identity, requesting another transfer that requires an Exceed identity, here using OAuth to perform the authentication, and then finally repeating these tasks with various applications. So just in case you're not familiar with OAuth, the basic idea is if I want to, here in this case I'm authenticating to Globus Online with I specify, you might see in common up there, but here I want to authenticate using OAuth, using Exceed, And what Globus Online then says is, okay, I need to redirect you to Exceed, and I go to an Exceed page to actually perform the authentication operation. So that's identity management. Let me say a few words about the group hub capabilities. So as I mentioned earlier, so simply being able to authenticate people is, of course, essential for many purposes, but being able to organize users into groups and then use those groups for purposes of authorization is equally important in many contexts. And the key point is you want to, in my view, take the group management capabilities, which have been implemented dozens, perhaps hundreds of times across the sciences in different contexts, and provide it as a service that can be used by any person, any project, while being customized in whatever way they may require to their particular purposes. And that's what our group hub does. So users can create groups, they can manage groups, they can define their admission policies, their visibility, and then once you've defined a group is basically just a named entity that you can refer to in authorization policies as required. So for example, the knowledge base project, the KBase project, they every time they register a new user, by default it gets added to a group called KBase users. There are also other KBase subgroups, things like, I think there are some listed there, staff, microbes, Enigma, I'm not sure what that is, it's an Enigma, and so forth. And they use those groups quite extensively for access control. And again, we have a nice web interface for managing group membership, for specifying, for monitoring the status of a group. In this case, this group has a set of pending invitations, etc., and for specifying the policies that may apply to that group. Okay, so I'm almost done here. So I've reviewed at least 3 of the 4 capabilities that we provide for this group service. Well, we started off Globus Online simply providing a data movement software as a service offering. As we've started to develop out this platform as a service, we're taking it fairly slowly, but we're starting to see a growing number of groups that want to basically hand off these capabilities to us. And one way we do that is by providing a set of branded sites. So anyone who wants to can basically take our REST APIs and deliver them via a web interface that we actually will host for them if desired, which provides their own branding, look and feel. And here's a few of them listed, a mix of universities, projects like KBase and large cyber infrastructures like Exceed and the Open Science Grid. A few words about implementation. So as I said, we host all of these capabilities on Amazon. We have I think, probably fairly standard set of approaches to achieving high availability and elastic scaling. You're running multiple versions of our systems in different availability zones, replicating data across availability zones, operating our own operations and security management infrastructure, logging, monitoring, and so forth. And I'd say we found Amazon to be a highly reliable place to host these sorts of services. Last year, there were, I think it was last year, there were a number of high-profile incidents in which some Amazon components went down. We never lost more than a couple of minutes of availability due to those. Our usage, this is Globus Nexus usage, is been steadily increasing. We haven't been advertising it too widely, but we've still grown up to 12,000 users, almost 5,000 linked identities with those users, and about 557 groups as of whenever I collected this information. Most groups so far are pretty small, but there are, as you'll see from this log scale plot here, some large ones. The largest has 402 users. So I thought it might be interesting to mention the following, just briefly. So I'm involved on the architecture team of the EXCEED project. This is a National Science Foundation project that links primarily supercomputer centers around the US, but that aspires to be a provider of cyber infrastructure services for the scientific community at large. Currently, EXCEED has a somewhat organically developed set of identity and group management protocols and mechanisms. There's a couple of different identity services, 3 or 4 different group management services. So we've are currently working on we've developed a proposal to replace these, what I might say, ad hoc systems with uniform use of Globus Nexus identity and group services. We believe that in so doing, we will reduce complexity, reduce cost, and most importantly, I think, increase capability, because these services will then become available to any user of national e-science cyber infrastructure. So we've been going through a pretty careful process of documentation and review as part of this. They like documents in EXCEED, which I guess is a good thing. We have an architecture and development requirements process document, which is a quite detailed set of requirements stating exactly what is required for creating, using identities, groups, etc., linking them back to a fairly extensive set of use cases that's been collected by the EXCEED architecture team. There's a detailed proposal, a list of use cases that will be affected by or benefit from this, and a set of motivating stories, so we could easily share those with people here if there was an interest. We hope to reach closure by the end of 2013, so I'm sure you don't have any of these problems, but EXCEED is a large distributed system with many actors, and it's not always clear who needs to say yes to something before it can happen. And so we're gradually working through who those people are and persuading them, we believe, of the merits of our approach. Okay, so that's all I have to say. I think the lesson that I've learned, at least over the last few years, the last 2 or 3 years, is that this notion of software as a service, platform as a service, the notion of taking capabilities previously delivered to people via software and operating them as cloud services can have a transformative impact on how easily and how readily people make use of powerful capabilities, the sorts of powerful capabilities they need in their science. And I think it's a combination of embracing Web 2.0 capabilities in terms of very intuitive interfaces, learning over many years what exactly it is that people want and working out how to provide it easily, and reducing basically the barrier to entry for making use of these capabilities. And we seem to be learning that people really get very excited when you can offer them these things in a way that is intuitive and convenient. My long-term vision remains trying to do far more than just identity and data movement, of course. And we have a few other projects that are not as far along that are looking at other aspects of the research data management problem. Ultimately, I do think we can have a transformative impact on science at a very large scale by allowing many more people to engage in research, especially big data research, by virtue of providing appropriate cloud services. I should thank my sponsors, which are listed here, and then thank you for your attention.
Will Globus sit on top of the commercial cloud, or do you see two independent communities with some overlap?
Yeah, so I think cloud for me is as commercial cloud, say Amazon in particular, I know there are others, has, I think, can serve two important and different roles. It provides a wonderful place for hosting highly available services that are relatively inexpensive to operate, things like a data transfer management service. And then it can provide certainly a highly elastic, but sometimes relatively expensive place to store large quantities of data or to perform large amounts of computation. I've been emphasizing in this presentation the first of those roles, and I think the opportunities there are enormous and still can be tapped to a much greater degree. The role that cloud will play as a place for storing data and performing computation, I think, remains to be determined, but my view it will be there's tremendous opportunity there as well. But I do expect that the future, at least for the time period I can foresee, will include a mix of campus systems, national facilities, and commercial cloud services. One thing we're doing, I think I have a, I thought I had a slide there, I don't, I guess. We've been running, we have a project called Globus Genomics where we're running genome sequencing services in the cloud for small labs, and we find there that it's a wonderful, works wonderfully well. These are small labs that they're paying $1,000 per genome or a few $1,000s per genome to sequence them, so paying a few tens of dollars to analyze them in the cloud is not a significant cost to them. So they find it very attractive because the alternative would be to acquire substantial hardware and expertise in-house. But on the other hand, someone like a high-energy physicist is not going to be able to run efficiently in something like the Amazon service. Yeah?
And there are a variety of actually not bad reasons for doing that. You get an association with a real person, for example.
Yep.
And you can be pretty sure that whoever it is has a Facebook account. So have you considered that for Exceed? And if so, why? And if not, why not?
Yeah, that's a good question. So it has been proposed, but it hasn't gone anywhere as yet. We don't currently provide a way of linking Facebook identities with Nexus, it turns out. I think that's because of lack of demand for some reason. As to why Exceed would not accept Facebook identities, it may be, first of all, purely sociological. It doesn't seem serious. There is a requirement that they have for email authentication, email verification, which I'm not sure if Facebook offers that. But in general, I think one should be embracing these commercial services wherever possible. Well, thank you very much.
So Ian, thank you very much for coming. I think this gives us a lot to think about, both in terms of what we're doing in Genie with identity and authentication, how we can merge our efforts with those of related efforts in cyber infrastructure, and what we should be thinking about in terms of more sophisticated policy representation as we go forward. So our next talk is an update on international federation efforts that are going on between Genie and peer testbed efforts worldwide. Brecht Vermeulen from iMinds in Ghent, Belgium, has been leading a little group, and he's going to report on progress and basically show us what's going on. So, Brecht?
So good morning, everyone. So as Mark has introduced me, I will tell something about international federation, some tests that we've done. I'm from iMinds Research Institute and Ghent University in Belgium. And in the Fed for Fire project, which does federation in Europe about testbeds, I'm the lead of the architecture work package. So the goal was stated in the previous GEC by Larry Landweber. So the question was, what can my student do now on international testbeds? And so also the vice versa, what can a European student do, for instance, on GENI testbeds? So the testbeds involved, so I upgraded the world map a little with the testbeds. So we took the GENI, Insta-GENI and Exo-GENI racks. In Fed for Fire, we do have a large number of testbeds of a very diverse origin. There's also Exo-GENI racks in Amsterdam and also in Australia, in NICTA. There's the Proto-GENI testbed in Brazil. And there's in Japan the vNodes testbeds and also the Flare project. So those were the things that we considered. So what is the current state of those? What we did is, because in the Fed for Fire project in Europe, we already had to test all the AM implementations, the compliance of the different testbeds to the standards. We have developed a tool for that, and it's called JFET. And so we took that same tool and we tried it on the other testbeds just to see how it would work. So what we did is we took a certificate of a Fed for Fire authority, so being a European student, for instance, and then we did some tests. So the tests involved aggregate manager tests, for instance, get version, list resources, but also full scenario tests. So creating a slice, putting a node in that slice, doing an SSH login on that slice, so really doing the whole workflow of an experiment. So we put up a little monitor. So you can't read, of course, the details, but every line is in fact a testbed or a rack. Green means that it is successful, red is some failed tests. So at left we see, for instance, the get version list resources test, which means in fact we ping the testbed. So with a get version, you know the AM is up and running, you get an answer. List resources means already that your certificate is accepted, so we already test that. And at the right, we do 2 times every 24 hours the full SSH login test. So at the bottom you see the URL, so this monitor is up and running and does its work continuously. We also looked in layer 2 links that could be stitched. So there are links between US and Europe. So iMinds has a connection to Internet 2, also Amsterdam University has a connection. Then there's a connection from Australia to Genie, to Internet 2, and there's also one between Japan and the US. So those can be used for doing stitching between the testbeds. So we did also test that layer 2 stitching. So here you see an example with JFET where we drew a topology with a node in Belgium and one in the US on Genie, and with a stitched link. So this means that we both have a European tool which does the stitching. We do have the connectivity between those testbeds, and it all works. So even also with Omni, you can just set up that link and test it. Another thing that was done in the working group was about uniform clearinghouse APIs. So there were some APIs for member authorities, slice authorities, and registry where we tried to put up a specification. So with the GPO, Utah, Ophelia project, and also iMinds. And here we did both implementations from the server side, so the authority itself, and also the client side, meaning the test. So what you see is the 3 different APIs, and each green thing is a function that is tested successfully. So we did develop the tests together with the implementations of the server side. So what are now next steps in this international federation? So first, it seems that the aggregate manager API is stable and interoperable between the different sites. There are some minor details that could be solved in a common API, but these are not that big differences. So then APIs for authorities, for instance, member slices, and also for getting a list of authorities. These are, well, not standard or not present. For instance, I do know of a way to get a list of all the AMs in Genie. So we got to talk to different people and ask what kind of AMs are present and so on. So the uniform clearinghouses in the previous slide have functionality for doing that. So you can register all those authorities, those aggregate managers, and then as a tool you can get a list of those. Resource description, because of the variety of all the different testbeds, they all speak different R specs, and for tools it's not that convenient to show all those resources. So there's currently an ongoing European Genie efforts to see if ontologies could solve or could improve this. Stitching, yes, it works. It's not simple. So what we see is trying to get more stable implementation in tools, so also the feedback to the experimenters. It was also discussed yesterday at the INM session. So there is feedback for real experts, and you know what happens. But tools should, for instance, retry VLANs and VLAN numbers and retry again. So it can take some time. So at that moment, you should have very good feedback to the users. Also in Europe, we have a GA network with Autobahn, which does dynamic circuit setup. But there's not an aggregate manager on top yet. So for instance, the iMinds testbeds, we have a direct connection to the internet too. And we use the aggregate manager of the internet too for that. Tools that are easier to use. So there's very complex functionality, but in fact, we should try to hide that to users, I think. So for next GEC, what we could try to do is, so the Japan people about the Vino testbed yesterday at the demo night showed that they have interoperability between an aggregate manager on top of their Vino testbed and the Proto-Genie one. So we can try to do this also in our tests and see if, for instance, with JFET tool it works and so on. For Ophelia in Brazil, the OpenFlow testbeds there, they are planning to deploying the Ophelia framework, which would be an aggregate manager and a clearinghouse. So at that moment, all those testbeds are also accessible through the standard APIs. I think we should try to deploy a federation clearinghouse. So at that moment, you can get, for instance, list of all the authorities, all the aggregate managers in a standard way. So the implementation is almost done, so I think we should just deploy one and try it. As the monitoring site, which has been shown, is continuously running, so this means every 15 minutes we do a get version and list resources to each AM, and every 12 hours we do a full SSH login test. I think at next GEC we might have some nice statistics about how much things fail or not. And we also add those on stitching tests. So then we do every night a stitching test with full SSH login and a ping between the two nodes to see if it actually works. And then I think also the tool improvement, so making tools simpler, more robust, for instance, for stitching, would be a nice goal for next GEC. So this was my last slide. So I want to thank all the people because they were involved of all the continents. And so you do phone confs at strange hours. People have to wake up early or stay up late night. So I would thank everyone. And I think we are making nice progress on International Federation. Thank you.
Thank you, Brecht. I think that this continues to be important work on which we're making very nice progress, and we really are rapidly approaching the day when the answer to Larry Landweber's question of, what can my student do now is, well, he or she can grab a transcontinental configuration that spans South America, North America, Europe, Asia, Australia. That's 5 continents, mind you. And he or she doesn't really need anybody's permission to do that. So that's the kind of goal we're shooting for. We need to remind ourselves that every single point along that path takes work, and I think that's what we're going to do now. In a minute, I'm going to introduce Marilyn McMillan, who's been patiently standing in the back of the room for, thank you, Marilyn, for quite a while now. But Marilyn's going to speak on behalf of a group of 4 people who are listed in your agenda. Herself, William Owens, Jim Carianis, Oswaldo Hernandez from NYU and NYU Poly, who've been involved in bringing Genie and Genie equipment here on campus, both at NYU and at NYU Poly. And then after Marilyn, Tom Schmidt, who's the CIO from NYU Poly, will talk a little bit about some of the specific work we've done in support of, I promise you, there are 2 demonstrations at the end of all this. There's a lot of effort that goes on campus. We are repeating this effort time and time again as we deploy Genie across the country, and I'm just delighted to be able to invite a couple of the people who have been so key in making that happen right here in New York to tell us a little bit about that. So Marilyn, thank you for waiting.
Thank you, Mark, and good morning to all of you. I'm relieved to see the slides actually on the screen. I whipped in with my stick not too long ago, and this is really great service. I'm also very happy to see all of you here in New York. The last time I was in a Genie crowd, we were in some other part of the country, and it's great to have you all here in New York and not to be having a hurricane or a superstorm, as it came to be called. I particularly want to thank Professor Caracas for having been the inspiration behind this gathering and for the work that he and his team have done. If it hadn't been for the work of Professor Caracas and his team, we would not at NYU yet be part of Genie. When we first learned how to spell Genie, which was sometime before we met Professor Caracas, we couldn't find a faculty member at NYU who was particularly interested. And so from the point of view of IT operations, we took a step back and figured, well, maybe when the time comes, we'd like to be ready, but it appears as yet the time has not come. And the wonderful thing is now it has, and as part of the affiliation that NYU has with NYU Poly, we're deep in the thick of being involved in Genie, and I'm really pleased to be a poster child for the rapid growth goal that Mark talked about earlier. We're one of those rapid growthers. But as I was thinking about the framing for this talk, which is only a couple of slides, it occurred to me that there was a story that's relevant to the way I feel about being in this room with all of you who've been working so deeply and so much and so long on this whole domain of network research, which is so important to the future of everything we've got going in higher education, not only in the States, but around the world. There's a story about a federal agency program director who had some time on her hands a couple of weeks ago, and she was thinking about forming a panel of experts to explore some very important new initiatives in cyber infrastructure. And she went to one of the delis in Washington, D.C., looking for brains. And she was led to the counter by the deli sales guy, and she said, well, I really need some very good brains for this cyber infrastructure futures exploration project. And he said, well, we have federal agency employees who are very deep in that space, and we have those brains at about $200 a pound. And she said, well, yes, I'm going to need some of that. And then he said, and over here we have computer science faculty brains. Those go for about $500 a pound. And then a little further down the aisle, there are CIO brains. Those go for $5,000 a pound. And the agency director said, well, that's impossible. How possibly could CIO brains be 10 times more expensive than computer science faculty brains? And the guy behind the counter said, you have no idea how many CIOs it takes to get a pound of brains. It's cool to be among all your brains today. Thank you very much for having me. I just first want to start by introducing a little bit about New York University. New York University is a private university based here in Manhattan, founded in 1831 to be in and of the city, one of the first universities in the States that was modeled after the University of London, a practical, pragmatic university where the, at that time, sons, but pretty soon daughters too, of the mercantile class in New York City could be educated. And we have grown big time. We have an enrollment of some 51,000 students, about half and half, equally divided between undergrads and graduate students, and then another bunch who are involved in non-credit programs, not only here in Manhattan and in Brooklyn, but all over the world. In fact, we had laid out a few years ago an aspiration to become the first global network university, and we're well on our way. And when we use the word network in that phrase, global network university, we actually mean not the boxes and the wires and the circuits. We mean the people and the ideas that flow in a network. And in our case, it's a network of what we call 3 portal campuses, one here in New York, one in Abu Dhabi, one in Shanghai, and about 16 sites for global study and global research around the world. This is what our NYU global network of circuits looks like today, connecting those sites. And you can see, I hope, that in New York, we have a connection not only in Manhattan and Brooklyn, but also up in Syracuse. In fact, this is a too large-scale map to be able to show you the details of the connections across the East River. Frankly, it took us a little longer to get the high-speed pipe across the East River than it did to get the one to Abu Dhabi. But in any event, this is what we look like today, using a combination of commodity internet, national research and education network, and commercial circuits to create this connectivity where services for the university, things like our learning management system, our student information system, are actually served out of New York City to all of the sites and all of the classes, all of the students and faculty and staff who are located in those various sites. This fall, for example, we opened our campus in Shanghai with about 400 incoming freshmen, half of whom are Chinese nationals, well, 51% to be precise. And those students will begin their 4-year undergraduate odyssey and get an NYU degree from NYU Shanghai in Shanghai, but spend at least 1 and probably up to 3 or maybe 4 semesters elsewhere in the university's network. Last year, for the first time here in New York, we were a study abroad site for the junior class members who were studying at NYU Abu Dhabi. And that's the flow of faculty and students, ideas, and research that we're trying to promote with this connectivity of technology network, so that faculty members here in New York and Brooklyn, for example, can have accounts on our high-performance computer which we call Butina, that's located in Abu Dhabi and vice versa. Now, when we talk about this network, it's a combination of any number of pieces that we're referring to as NYU's blended WAN. And I want to walk you a little bit longer through this chart to just kind of describe what the elements of our blended WAN are. And you'll remember that our new Genie racks are now in place and part of that blended WAN. And our new Genie racks also connect us as part of our NicerNet membership to the NicerNet Genie racks in upstate New York. And through those racks, we're collaborating with our New York State University research partners at Columbia and Cornell and RPI and RIT to be able to do support their experimental work with Genie as well. But any one of our main campuses, today that would be New York and Abu Dhabi, and a facility that we share with Internet 2 in Singapore, contains a network hub that has the key routers that mediate our global network connectivity between the campuses and across to our global sites. You can see that our connectivity model includes the combination of those services, and we're trying to be flexible in the way we set those services up so that we can take advantage of emerging features or lowering costs. As you can imagine, this is a pretty expensive enterprise to run, particularly if we have to depend only on commercial circuits. And so we count very heavily on the partnerships we have with Ghent in Europe for our sites there, with Garnet in Italy, with Ankabut, which is the network in the United Arab Emirates. That's the NREN there. And we've been working with CSTNet and CERNET, the education and research networks in China, as part of our build-out of the Shanghai campus. So we need to have at each of these hubs the facility to be able to move circuits in and out. Now what we do is we build our secure encrypted VPNs over these networks, and all of the traffic between our campuses is routed over these VPNs. VPNs are the circles. I'm glad these colors are showing up, the circles on the right-hand side of the diagram, and you can see the faint mesh. That's cool that you can see the faint mesh of connectivity that are those lighter lines. On top of these VPNs, we apply technology such as WAN acceleration to help compensate for network latency and bandwidth limitations. We apply quality of service. You can see the QoS circles there to manage the use of available bandwidth. And we also conduct our own application-based routing. That's our term. To determine which IT services and applications should be directed over which VPN. Now, the combination of these three techniques and the use of Internet, NREN, and commercial services is what we call our blended WAN. And although many of these features of our blended WAN could be software enabled one day, the greater immediate benefit would come from getting support for application-based routing. Application-based routing is helping us increase our network connectivity value, whatever the bandwidth, and manage the operating costs much more efficiently. If I want to look ahead to what I hope Genie will accomplish, I hope it will accomplish a couple of big things. I hope it will provide an environment for network research of all sorts to continue and to capitalize on the kinds of infrastructure that our universities are building for our production purposes, in our case at NYU, all around the world. And I also hope that there will be results from Genie that will help us manage this increasingly complex environment so that we don't have to scale the number of network technicians who operate it to the same level of the number of boxes and wires that we have in the environment. So if I were looking at what I would like to see from an operations point of view out of that, I would like to be able to place bandwidth intensive and research data transfers over the high bandwidth NRENs for VPNs. I would also like to bring the environment to a place where routing intelligence could include dynamic factors, such as knowing what the currently available bandwidth is on any one place, knowing what the latency is on any one path, and being able to accommodate changes to it without a person having to intervene and look at those issues. That's it. Welcome and thank you.
So thank you, Marilyn. I'd like to also thank you for including 2 items in your talk. One is reminding us that New York is really a city with everything. I was watching CNN over the weekend, and there was a fundraiser that involved a zombie walk. And I guess you have to walk far when you're in Maine to get brains. Here you just stop in the deli. So, and more seriously, thank you for mentioning the role that NYSERNet has played in our rollout here. Regional networks are a very important element of Genie strategy, and NYSERNet has been very important, and it was good for you to bring that up. Thank you. So Tom Schmidt is our next speaker. Tom's going to speak, I believe, without slides. And tell us a little bit about sort of specific preparations that have been going on here at NYU Poly, and then we will actually see some of the demos that this work has enabled.
When Professor Caracas told us that we were going to be the host for GEC18, we were thrilled and proud because and we are a research and an engineering institute most of. So we were really enjoying that, and then all of a sudden we got nervous. How are we going to pull this off? Because these are the people that are doing the things that we always dream about. Happily, that same collaboration that we have with NYU was there to help us in doing the plumbing that we needed to do, and we hope you don't ever see for your conference. And they were between BBN and between NYU, the collaboration and the help, it was just more than we could hope for. And the other thing is that when you see IT people, we're generally pretty good at hiding our enthusiasm. But when we actually started out and decided to start doing the planning for this project, the people were genuinely enthused, and I was really surprised at that. And then I feel that the people were proud and they were happy to be able to support this project. And I think the reason is because they actually respect all of the research that's going on this project. And unfortunately, that's all I have to say today.